Hello, everyone, and welcome to the next part of our lab. Our lab is broken into multiple segments. We just got done with the reflection part of it. Now we're dealing with the refraction part of it. Reflection previously was just a phenomenon where light could be reflected from a surface, a smooth or rough surface, back to the direction from which it came, or back to the medium from which it originated. That is just a phenomenon. We've been able to see that with sound waves, with waves in the string, where we created stationary waves. If you remember, that was our first lab. So basically what was happening was a wave was going from one end to another and got to a certain point and was reflected. We just did that same thing with light waves. Now we're going on to the next phenomenon that we are analyzing in this lab, which is refraction. Now with refraction, when light energy gets to the surface separating two medium, it's not totally reflected. It is predominantly transmitted. That is, it crosses from one medium to the other. And in the course of doing that, because the medium have different intrinsic properties, the light wave gets bent. That is what we're going to experiment. And in order to do that, we are going to use, as usual, our pins. All right, we will have pin 1 and pin 2. I'll show you why they are. Pin 1 and pin 2 are these two pins with white beads at the end, on the surface, at the tip. Make sure you can see that. Yeah, pin 1 and pin 2. I'll put them right here. And then we're going to have pin 3 and pin 4 right here as well. Now, they don't have beads at the end, okay? They're just regular pins. And we will have a glass block. The glass block will be the material that will create a boundary on our setup. So, for example, when I put my glass block right here at the center of my paper, this side of the paper is plain air, right? It's just air. So for a light ray here, it's just traveling to air. But when it goes into the glass block, that is a totally different material. So at the surface here, we're going to have a transition between media 1, which is air, and media 2, which is glass material. And because of that change in medium, we will have refraction. Light will be transmitted and bent. That light ray, while it's transmitted, will also go from glass to air when it gets to this boundary. And because it will be a change from one medium to another, we will again have refraction. So how is this process going to work? After putting our block on our paper, the paper has an A4 format. It's blank. It's placed on a green a lid of a box. The lid is made of cardboard. To make sure things stay pretty much in place, even if something falls apart, we're going to map out the position of a block. Note that all through this process, I did not touch the clear surfaces of my block, right? Like if you look keenly, you see that transparent surfaces that I don't touch, all right? This is a little bit cloudy, so I can hold it there, but this is transparent. So you want the light ray to go through the transparent surface while you hold the glass through the foggy or the clouded surface or sides, all right? So I'm going to make sure my transparent side of my glass faces me here and faces this other side while the clouded sides are here. Then I'm going to map out the position of my block. Now, the purpose of this is to make sure if something happens, I can reposition my block, and then when I take off my block to do my measurements, I kind of know where the boundary was, where the glass block was. So it's kind of giving you, what will I say, position details of where your material was. Now, the glass is in place. Other tools I will have to use will be a ruler and a protractor. Okay? All right. What will I do? I will take my incident ray, which is made up of 2 pins, right? Remember the pins with the beads on the end, okay? And on this side, I'm standing on this side. I will be on the side, but I'll be more to my right, okay? So I'll be standing to my right to mimic a light ray going from right to left, all right? And in order to make sure I mimic just a single ray, I will have my left eye shut. So everything will be based off my view, my line of sight from my right eye, because that means I'm dealing with a single beam of light, which I can approximate with single ray by using the pins, okay? So this is what we're going to do. I am on this side. Remember, guys, I'm on this side. Take off this rod, which we don't need. And then, instead of putting my pin 1 all the way at the edge here, as it was with the case with reflection, I will put my pin 1 here at the air glass boundary here. All right? And then my pin 2 will be somewhere here at the edge of my paper, but I will put my pin 2 in such a way that it overlaps pin 1 on my line of sight. So initially, with my left eye closed, I can see pin 1. Now I'm taking pin 2 without moving my head. I want to make sure that pin 2 overlaps pin 1, such that when I look at everything from this line of sight, I cannot see pin 1 because pin 2 is covering or concealing pin 1, okay? So right now I have a ray going from my right eye. It hits pin 2, and I cannot see pin 1 because pin 2 is covering pin 2, but the ray should have gone, if it went freely, would have gone in a straight line from pin 2 to pin 1 onto the glass air boundary right here. Now, with that being done, I will go to the other side. So I'm on the other side. As you can see, the position of my hands have switched. I was on that side, now I'm on this side. And I'm going to use pin 3 and pin 4. And I'm going to do everything from this side of the setup, okay? We talked of a light ray going from right to left. When I was on that side, this was my right. And this was my left. So the light ray will come like this, go through my block, then come out this way. So how do I do it this time around? I will take pin 3. And what I will do with pin 3 will be quite interesting. Here's where, excuse the noise. I will take pin 3. When I look at this surface here, I can see pin 1 and 2, okay? What I want to do is make sure that I move with my left eye closed. I move my head such that the line of sight of my right eye ensures that the image of pin 1 and 2 that I see through this glass block overlap each other. So I look at a glass block here. I move my head left, right, until the image is not this objects. I look at the image from this surface, okay? You don't look above the glass. You look through the glass. I look through the glass where I see the image of pin 1 and 2, and I move my head until those two images overlap each other, and then I place pin 3 such that pin 3 overlaps that overlapping images, all right? So now I have image of pin 1, image of pin 2, and object pin 3 overlapping each other when I look at this glass surface on this side. Likewise, I will now take pin 4 and bring pin 4 to the edge of my A4 format, but making sure that pin 4 overlaps pin 3, which is touching the glass surface. So the net result is that pin 4 covers pin 3, and pin 3 covers the image of pin 1 and pin 2 seen through the glass surface. All right. So now we have 4 pins, 2 on the incoming side of our glass block, 2 on the outgoing side of our glass block. We made sure that pin 1 and pin 2 were in my line of sight such that I couldn't see pin 1 hiding behind pin 2. And then when I came on this side, I made sure that the images of pin 1 and 2 seen through the glass block were overlapping with pin 3. And that subsequently, pin 4 was covering the object pin 3 and the images of pin 1 and pin 2 when looked from a line of sight on this side of the experiment. I know it's a little bit of too much information to send out there, like you're not there to ask questions, but let me just explain again what we did. We placed our glass block. We made sure that the clear surface or the transparent surface of the glass block were here. The transparent surfaces were here and here. All right. We put pin 1 here, making sure it touched the transparent surface. And then with my left eye shut, I had made sure my line of sight allowed me to place pin 2 such that pin 2 overlapped with pin 1. That was representative of a light ray. And then I came to this other side of the board. On this other side, with my left eye shut, I looked through the glass now, and I could see the image of pin 1 and pin 2. I could see the images of pin 1 and pin 2 through the glass. And I moved my head sideways until the images of pin 1 and pin 2 seen through the glass overlapped. And then I placed pin 3 on that overlapping view such that pin 3 covered the overlapping images of pin 1 and pin 2. And then I placed pin 4 such that pin 4 overlapped pin 3. All right, so the net result is pin 4 is covering pin 3, and pin 3 is covering the images of pin 1 and pin 2. All right, with that being done, I can take off my pins because the holes have been bored on my paper, right? I can take off my pins, put them somewhere because we're going to reuse them for another refraction experiment. And I can take off my block. Remember to hold the block on the cloudy side, on the foggy side, not the transparent side. Now, I'll take my ruler and connect pin 1 to pin 2, like this. And I can extend that line a little bit further. All right. This is one of my rays. And then here we go with the other ray here. I'm connecting pin 3 to pin 4. I can extend it a little bit further. You understand why I extend them with dotted lines? Because when the time comes to measure the angle, you wish these lines were long enough. So you don't want to make your drawing too crowded, but at the same time, you want to be able to see everything you're doing. So let me bring down the camera so we can sort of have a better view of what we're doing here. A little bit tricky, people. I'll move this paper a little bit like that. All right, some more like that. All right, I think that's good. All right. Okay. So again, this is the line going from pin 1, from pin 2 to pin 1, and the line going from pin 3 to pin 4. Now, this is my surface where everything happened. So we'll call this surface 1. This is the other boundary between glass and air, surface 2. All right? So I'm going to make a normal to that surface here. Okay, before I do the normal, right, I will take the position of pin 3 and the position of pin 2. I will connect them with a line. Now, what you will notice with this line connecting pin 1 and pin 3, it is kind of bent. Remember I told you that when light crosses from one medium to another, the net result is if the medium are different, the light ray will be bent. This is our light ray that came up to this boundary, got bent, right, when it entered the glass, and when it left the glass, it got bent again, all right? Now I'm going to draw my normal to the surface or to the boundary between the two medium. All right. Here's my normal. I call that N normal 1 for surface 1. And here's my other normal, all right? I call that normal 2 for surface 2. So this line that connected pin 1 and pin 2 is my incident ray. I call it I1. And then this line that connected pin 1 to pin 3 is my refracted ray. I call that R1. But that same line, when you look at surface 2, is the incident ray. So it also becomes I2. And this fourth line that connected pin 3 to pin 4 is my second refracted ray. I call it R2. All right? Okay. I just hope the whole video is good. Now let's collect the data which we'll use for results. So we take our protractor and we measure the angle between the incident and the normal on surface 1, the refracted and the normal on surface 2, the incident between the normal and the angle between the incident and the normal on surface 2, and then the angle between the normal and the refracted of surface 2. I kind of wrapped my tongue there. Let me go over that. So we're going to measure the angle between incident 1 and normal 1, refracted 1 and normal 1. All right? Then we're going to measure the angle between incident 2 and normal 2, and then the angle between refracted 2 and normal 2. So let's do that. I put my protractor right here, and the angular distance between the normal and the incident here goes from 90 to 54, right? That is 90 to 54 is about 10, 20, 30, 36 degrees. So I have a 36 here. Now measure the angle of refraction. And that angle of refraction is the angular distance between 90 degrees and 67. So 90 degrees and 67, that is about 23 degrees. All right. So this can be called theta I1, and this would be theta R1. All right. That's incident 1, refraction 1. Now for the angle of incident on surface 2, I put my protractor such that I can measure the angle between normal 2 and incident 2. And that angle goes from 90 to 66, which means I'm dealing with what? I'm dealing with 24 degrees for my angle of incidence of surface 2, which I can also call theta I2. And then I measure the angle between my normal, right, and the refracted ray from surface 2. And that is the angle sustained between 90 and, let's see, 90 and 54. That corresponds to 36 degrees. And that is my theta R2. All right? So, folks, we have here the complete setup and data for the reflection through a glass block. The next video on this will show you how to process this data to get results and to analyze properties of refraction. Thank you, and see you on the next video.